In the present video, we're going to talk about the use of units when defining matrices or vectors of data, as well as the application in graphics. For that purpose, we're going to start with this SMA Studio file, where I have defined a vector called masses to enter a particular element. Is as simple as typing, for example, here 1.4 apostrophe slug slug. In this vector, all the units have the same dimension, masses. And so if I type, but to produce this result, all you have to do is type masses equal, and it gives you the conversion, automatic conversion of all the elements to the units, the basic units of the international system, which is kilograms. And that's what you get. Now, if you wanted to produce a result like this, what you have to do is click on the right-hand side of your last result, where you have kilograms, and type apostrophe kg right here, and then you get this result. Actually, you could have done it right here. Well, no, you actually have to make a masses equal to produce the change of units. So we've done that, and that was the result that we started with, and this is what we ended up with. Now, in this case, I have a vector where I have different dimensions. These are dimensions or units of mass. These are units of force, mass again, and force. So when you do that and you make it equal to, you get the units of the basic units of the international system: mass, kilograms, force, kilograms times meter per second square, which is Newton, but they prefer to give you the most basic units. And so this is what we're getting for these four results. There's no way to produce a common unit for this because they belong to different dimensions. But if you click here and you type apostrophe kg, then you're going to get this result where every element in the vector has been divided by kilograms, giving you the remaining units. Right. So what I've done here is repeat the V equal and extract as common unit the Newton, for example, the kilogram here, the Newton here, slug, and pound force, and you get different numbers because the remaining units here have been divided by different summarizing units, I would say. Let's see, if all of the elements have the same dimensions, like here would all have dimensions of forces: Newton, pound force, dynes, and ton force. Of course, when you make equal to, you get the basic units of the English system. But you could extract as a common unit one of the particular units of forces, like newtons in this case, or dynes in this case, and you get vectors of numbers without any unit attached to it, except for the one that's outside. In the following example, I'm using a matrix. This matrix has 3 by 2 elements, 3 rows and 2 columns, where all the units are units of pressure. So when I make the equal sign, I get the basic unit of pressure on the international system is the Pascal, which is a Newton per meter square. But the Newton is kilogram times meter per second square. And so when you simplify things, you end up with kilograms per meter times second square. If you take a common factor like Pascal, for example, you get your matrix of absolute values all multiplying Pascal. We could change this to, I don't know, for example, bar, which is another unit of pressure, and this will be the result. If you want another format to present data where all the elements belong to the same dimensions, will be to divide the name of the vector or matrix by an appropriate unit, like pound force in this case, or bar in this case, to provide only the absolute values to the right-hand side. We're going to be using that with graphics. And here we divided by pound force. We could have divided by Newton. I'll give you a different value. and here we could have divided by atmospheres, and it will give me different results. All right, so this is regarding the use of units in vectors and matrices. Now we're going to be talking about graphics with matrices, or functions actually, that carry units. The example I'm going to talk about here is the case of projectile motion, where the separate movements of all the x and y vectors, or positions, sorry, are given by these two equations, the well-known equations of projectile motion. The first example, we're going to use units of the international system. We have the initial position, initial velocity with initial inclination, and gravity given by the standard constant available in the units of the SMAS Studio. If I type '(G.E) equal, I get this constant as part of the SMAS Studio, and I have assigned it to the variable G here. And then I'm going to define a function f1 of t corresponding to the x, and then a function f2 of t corresponding to the y. To produce a plot, I'm going to produce a range of values of time, and so to do this, I do tt column range parentheses 0, 5, 0.1. Then I do spacebar to get the entire right-hand side vector multiplied by seconds to give me my vector in seconds. I'm going to do Control Z here to backtrack. I'm sorry, I'm going to delete these two terms. So this is what I have produced right here. Now, if I want to produce my x coordinates, I do f.1 apostrophe, parentheses tt spacebar, and then I use my vectorization function here in the matrices panel, and that will give me values of x. Of course, it's going to give me the values for storage purposes in meters, although in the future we're going to be talking about using feet. Let's do Control Z to reduce that. This is repeated, so I'm going to delete it. And I have these two expressions where I calculate x and t. Now I have calculated the position of x and y, and I can produce a matrix mxy augmenting xx to yy. And in order to produce a graph, I'm going to estimate or calculate the minimum and maximum values of x, minimum values, maximum values of y, which allow me to produce an xy plot graph with x values between 0 and 90 and y values between -60 and 20 to enclose all these minimum and maximum values. Then I simply type mxy. Now, this works fine when you're working in the international system, because the units that you have in your matrix are in the basic units of the international system. But if you're working with units of the English system and define your functions and do all the calculations just like we did before, we find that when evaluating minimum maximum, we end up with meters. Then we convert to feet. Remember, to convert to feet, simply type on this placeholder and type apostrophe ft. And that's how I get these results. So I'm going to try to use those as my limits for x, right, between 0 and 80 to enclose those values, and y minus 90 to 10. Except that when I put mxy here, I get a graphic that doesn't cover those ranges. The reason is that my data is in meters and these positions are in feet, and so they're incompatible. In order to produce the right plot, what you have to do is take this matrix mxy and divide it by quote ft. And I'm going to do it right here because it's divided by apostrophe f. Sorry, mxy divided by apostrophe ft. And then you get the right graphic. And so be careful with when you use data in matrices or in functions in plots. If you are plotting two different quantities in the columns of the matrix, in order to produce the right graph, you want to reduce each one of them separately by the appropriate unit, time in seconds, position in feet in here, I'm just describing the behavior of the vertical distance y as a function of time. And in that case, my matrix is already dimensionless, and it's going to give me the right graph in feet for y and times in seconds. If I had not scaled down the units, then this is what I'm going to get, which is different than the actual graphic that I produced. Now, suppose that we don't have a matrix, but we have an equation like this one, where it's going to give me the vertical position as a function of time. I could just type F2 of TFS. I'm going to show you here how the steps. I'm going to do Control Copy, Control V, and delete this here. And then I type F2 of T. If I do that, nothing's going to happen because T needs to have units of time in order to produce results for F2. So I can say times apostrophe S. And now I get a graph. But the graph is wrong because this is in meters and my data here is in feet. And so if I divide this whole quantity by apostrophe FT, then I get the right graph. One more example. If we take this component of projectile motion, solve for T from this one, and plug it in here and in here, I get this result, except that I'm missing a square in here. That's the equation of the parabola that describes the motion. And I'm going to make it a function of x, so I can plot the graphic. And so the way that you would proceed is after you have determined the minimum and maximum values where you want to plot your scales, you proceed to type F.2 parenthesis T, and sorry, X. But that, of course, is not going to produce any result because the X needs to have units and the X needs to be multiplied by apostrophe FT, which is feet. Still, it won't show up because you need to scale it by dividing by apostrophe FT. I'm going to do a recalculate page in here. Oh, of course. It's F, not F2, so I get this extra 2 here. I'm going to go to the right, delete. Recalculate. Well, let me pause this. Something went wrong with the previous steps. I'm going to do Control C here. I'm going to paste it right here and remove the entry here. So this is the row graph that you're going to populate by typing F of X. When you type F of X, you get nothing in there. And then you click to the right of the X times apostrophe FT. And then it gives you something different than we should be getting. That's because this thing needs to be divided by apostrophe FT. And now you get the result that we expected. And with that, I'm going to conclude this particular video. And I hope you learned something about the use of units in matrices and graphics.